Hello everyone, welcome back to Let's Crack JEE in English. So let me check my voice. So here's my profile. So I'm Jeetendra Dixit. I did my BTech, my graduation from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for last 11 years. I teach mathematics, and we were doing complex numbers, cube roots of unity. We did last in this session, okay, in this slot. And today we'll discuss nth roots of unity. All right, so nth roots of unity and all the important points related to nth roots of unity also. Okay, so let me check. Yeah, but before we begin, let me tell you about the Unacademy's subscription. Okay, so you can buy two types of subscription on Unacademy. One is plus subscription and another is iconic subscription. So what is plus subscription? Plus subscription is when you get plus subscription, you get unlimited access to Academy's platform. Unlimited means you can access anything. I mean, all the educators, you can access all the educators' live classes, all right? So you can follow educator of your choice, all right? There's no restrictions. All the top educators of India are teaching on the platform, and you can access their live classes regularly, unlimited, if you have plus subscription, all right? uh, you can join some course also. There are always new courses starting every week, all right, so you can start fresh also. Even you can watch the recorded sessions. If you have missed something, then every session is recorded and you can watch that recorded session later also by downloading it, and you can watch them offline as well as online, all right. So that facility is there. You can ask your doubt during the live sessions, and asking doubt through you can send image, you can directly chat with your educator. There are dedicated doubt sessions as well which you can attend, and apart from that you can attend, you'll get access to all the tests and quizzes, all right, all the tests and quizzes on the platform. And all these courses are well structured. Well structured means everything is pre-planned, so you can see the schedule of all the upcoming lectures in advance, all right. So and let me also tell you about these special classes. Special classes every day, many educators conduct special classes on an academy's platform. Anyone can attend those special classes. You don't need to take any subscription for that. You don't need to pay anything for that. So all these special classes are free for everyone, and anyone can attend those classes. So even if you don't have subscription, just go and attend live classes, live special classes, all right? So as I told you, every day there are several special classes going on physics, chemistry, and maths. So attend those classes. During those classes, you can ask your doubts, you can interact, you can participate in polls. You'll get the feel of the platform, and same kind of sessions we have on Plus also, all right? So you'll get to know what kind of sessions we take on Plus. So there's a special class. I'm taking a special class at 8:30 today, in which I take doubts of mathematics. So you can come and join that special class as well. All right. So that's my special class on Academy's platform today at 8:30. All right. So come and join that special class. So this was about the Plus subscription. I hope you have got everything. And these are the subscription charges. You can subscribe for 1 month, 3 months, 6 months, 12 and 24 months. 12 and 24 months price is 38,500 without discount. And if you use my code JEET1, you'll get 10% discount and you'll have to pay 34,650. All right. Similarly, for 24 months, you'll have to pay 56,000. This is without discount. But using the same code JEET1, you'll get instant 10% discount and you'll have to pay 50,400. Okay. So these are the final prices: 34,650 and 50,400 per month. You can compare. Per month it is 2,880 in 1 year session, 1 year's subscription, and in 2 year subscription it is just 2,100 per month, just 2,100. All right. So this was the So this was about the subscription of plus. Now let me tell you iconic subscription. So iconic subscription, this is new, recently added to the platform. In this iconic subscription, you get all the benefits of plus. You can see you will get all the benefits of plus. That means everything which I've just told you on plus subscription, you'll get this, you'll get everything, all right, of plus. And apart from that, you'll get a personal coach. That means an expert will guide you for your throughout your exam preparation, okay, for your top exams like IIT-JEE Advanced and Main or BITS. All right, so for all these top exams, you'll get an expert who will guide you, okay, throughout your preparation. You will get test analysis with personalized feedback to improve your time management and exam approach. So your exam, any test analysis will be given to you in a personalized manner. And your study planner will also be customized, all right, and bi-weekly reviews will be given to highlight your progress. So these are the extra features you get in iconic subscription. And let me tell you about the pricing of iconic subscription. So you'll have to pay 56,000, all right, for 1 year, but you'll get 10% discount in this. Use my code Jeet1, you'll get instant 10% discount, and then you'll have to pay. Final price will be 50,400, okay, after 10% discount. Similarly, for 1 year, it is 86,000 for 24 months, this subscription iconic. And in this, you get 10% off using the same code Jeet1, and you'll have to pay 77,400, all right. So these are the subscription charges for iconic. So I hope these things are clear. Now you can download this Unacademy's learning app from Play Store, all right. Download this Unacademy's learning app from Play Store, all right. And start attending special classes. Okay, so today's topic is Nth Roots of Unity. We'll begin the topic. Nth Roots of Unity. You can find Nth roots of any number, but first we are doing Nth roots of unity, okay? So this is the equation which you need to solve. X raised to n is equal to 1. All right, x raised to n is equal to 1. So as we did cube roots of unity, a similar way we can find nth roots of unity as well. So first you need to write 1 in Euler's form. So in Euler's form it is e raised to I 2k pi, okay? You need to take general argument, which is theta plus 2k pi. So theta is 0, and you need to add 2k pi where k is an integer, right? Now you take nth roots, you'll get x is equal to e raised to I 2k pi by n, all right? Where k will start putting from 0, 0, 1, 2. We can put any value of k, but if you put 0, 1, 2, 3 and up to n minus 1, you'll get first n minus 1 values. Then after that, when you put n, you'll get the same value which you were getting for 0, all right? So the values will start repeating, okay? So you'll get n distinct values for n consecutive integers. You can take any n consecutive integers, any consecutive values, n consecutive values for k. You'll get k distinct roots, all right? And then after that, roots start repeating. So I'm taking first k values as z starting from 0 and up to n minus 1. First n values, all right, for k. So your first root x1 is going to be your first root if you put k is equal to 0, okay? So if you put k is equal to 0, your first root is going to be 1. E raised to iota 0, that is e raised to 0 and it is 1. Second root x2 is going to be when k is equal to 1. So when k is equal to 1, you'll get e raised to I 2 pi by n, okay? So I'm taking this root as alpha, okay? This root as alpha. Now you'll get third root x3 when k is equal to 2. So if you take k is equal to 2, it is going to be e raised to I 4 pi by n, right? And you can compare it with alpha. So if this number e raised to I 2 pi by n is alpha, then e raised to I 4 pi by n is nothing but alpha square. Okay, so these roots form a GP. Okay, that question is also you get in options that roots are forming a GP. So yes, roots are forming a GP. If you put k is equal to 3, if you put k is equal to 3 in this, then you'll get the next root x4, that is e raised to I 6 pi by n, and that is alpha cubes. Okay, so I've got you. I think you've got it. 2k pi by n, then next 4k pi by n, then 6k pi by n, then 8k pi by n, and so on, and then xn last root when k is equal to n minus 1. Okay, so this is the last distinct value, which is e raised to I 2 times of n minus 1 pi by n, which is alpha raised to n minus 1. All right, so these are the roots. These are the roots, and let's plot them. Let's plot them and see how do they look like in organ plane. So if you plot these n roots in organ plane, then what happens? See, 1 minute. I'm restarting. Starting 1 minute. We need to plot a circle. Okay, we need to plot a circle in this case. So let's plot a circle. I'll plot a circle with same color. Circle of unit radius. All right, circle of unit radius. All right, so this is a circle of unit radius. This point is 1 comma 0. All right, and as well as this is your first root. So if you start plotting the roots, then first root will be this only 1. The next root will be e at an angle of 2 pi by n. Okay, this angle is 2 pi by n. This is your alpha. The next will be 4 pi by n. Okay, so that depends on the value of n. This angle alpha 2. Then you'll get 3 pi by n. This angle is going to be 6 pi by n. That is alpha 3, and so on. Keep plotting these values. Okay, keep plotting equally spaced like this. Okay, so these are the roots. These are the roots like this. Alpha 4 alpha raised to 4, alpha raised to 3, alpha raised to 2. So this is alpha square, alpha cube, alpha raised to 4, and it's alpha raised to n minus 1. Okay, so these all the roots of unity lie on the circle of radius 1, whose center is at origin. Even if you join these roots, these points, these complex numbers, then you can see they will form a polygon. Okay, n-sided polygon. N-sided polygon, you can see it will have n vertices, so n sides. So nth roots of unity, nth roots of unity lies on the vertices of n-sided regular polygon. Okay, so that is the statement. I hope you have got it. These are the. Now I'll write some important equations. So first very important equation is Now what is alpha raised to n? So alpha raised to n will be e raised to I2 pi by n power n. That means e raised to I2 pi, and that is equal to 1. And yes, it should be, because alpha is the root of this equation, x raised to n is equal to 1. So alpha will satisfy this equation. So alpha raised to n should be 1. So yes, that is the first relation which you need to remember. Alpha raised to n is equal to 1. Very, very important relation. If it is fifth root of unity, then alpha raised to 5 is 1. If it is sixth root of alpha is 10th root of unity, then alpha raised to 10 is 1. Alright. So alpha raised to 2n will also be 1. Alpha raised to 3n will also be 1. Alpha raised to 4n will also be 1. Okay. Now second important relation is sum of the roots. So 1 plus alpha square plus so on up to alpha raised to n minus 1. Okay, alpha raised to n minus 1 is equal to 0. This is the second very important relation. First relation, second relation. All right, alpha is equal to e raised to 2 pi by n. Okay, iota. So by writing this e raised to I 2 pi by n, this n will tell you that it is nth root of unity. It is 2 pi by 11, then I'll say it is 11th root of unity. Okay, then I'll write alpha raised to 11 is equal to 1. Okay, so I hope you're getting it. Now let's do one example. If alpha is 7th root of unity, then alpha raised to 7 plus alpha raised to 8 plus alpha raised to 9 plus alpha raised to 10 alpha raised to 11 plus alpha raised to 12 and so on, alpha raised to 21. All right, this you need to find this value. So think about it, solve it, then I'll discuss with you. All right, so try this out. It's very simple. Alpha is 7th root of unity, 7th complex root of unity. All right, other than 1. Alpha is not 1, that you should write. Alpha is not 1. Or you can take, or this might be given in the question, alpha is equal to e raised to iota 2 pi by 7. In this way you can write. Then you don't need to, then you don't need to say that alpha is 7th root of unity in this case. You can directly write this. So alpha is 7th root of unity other than 1, or you can write alpha is equal to e raised to I 2 pi by 7. So that's sufficient to notice that it is 7th root of unity. So because it is 7th root of unity, then you can reduce the powers using alpha raised to 7 is equal to 1. So this alpha raised to 7 is basically 1, right? Then this alpha raised to 8 will is alpha, or you can find the sum of this GP. So I'll tell you two methods, all right? So first you can find the sum of this GP. That is a better method. So 21 minus 7, all right, plus 1. So how many terms you have? So you have 15 terms, okay? So sum of this is basically first term, which is alpha raised to 7, into common ratio, that is alpha raised to 15 minus 1 divided by alpha minus 1. Okay, so this alpha raised to 7 is basically 1. Alpha raised to 15 will be alpha raised to 14, which is 1 into alpha minus 1 divided by alpha minus 1. So finally it is going to be alpha minus 1 upon alpha minus 1, and you can write it as 1. All right, so that is going to be the answer. All right, so I hope you have got it. Now I'm telling you very important points. Okay, so point wise we'll complete the theory of this. Okay, important point, first important point. Okay, you can call this property also, and you can directly use it. So if alpha is nth root of unity, okay, then nth root of unity, alpha is not equal to 1, then find first is alpha raised to m plus alpha raised to 2m plus alpha raised to 3m and so on up to alpha raised to m times of n minus 1 plus. That's it. So basically you have put m power to all the roots. All the roots. Okay, let's add 1 also. 1 was missing. Now you have all the roots, alright? And you need to make two cases. Case 1, when m is a multiple of n, like on 7th root of unity, you are not putting power 7 or 14 or 26, or basically putting 7 power. So m is equal to ni, this is case 1, and case 2 is when m does not belong to ni. So that will be a good version, okay? Second part. So try this for a moment, then I'll tell you how to do it. Alright. So see, when m is a multiple of n, okay, multiple of n, like anything you can write, 2n, 3n, 4n, then alpha raised to k times of or I times of m will be 1, right? 1. It's an integral multiple of I. You can write this alpha raised to alpha raised to I into m can be written as I into I is new I n I, okay? So because m is a integral multiple of I, so integral multiple of n. So I've replaced m by n, and then you can write alpha raised to n whole raised to I, and which is equal to 1 raised to I, which is equal to 1, right? So all these terms will become 1. So there's 1 plus alpha raised to m plus alpha raised to 2m plus so on up to alpha raised to m into n minus 1. These terms will become 1. So 1 plus 1 plus 1 plus so on up to 1. How many terms you have? Number of terms n. So n. Alright. So that is your answer. You have n terms. Now what will be the answer when m is not a multiple of I? That means alpha raised to m into I or m into k is not equal to 1. Okay. Neither alpha raised to m is equal to 1. Neither alpha raised to 2I is not equal to 0, of course. Otherwise it will become 1. So alpha raised to m is basically, let's not write alpha raised to I, that will create confusion because you can take then some multiple of 7 also. So alpha raised to m we can write, alpha raised to m precisely we can write is not equal to 1 because m is not a multiple of ni, alright, m is not a multiple of ni. So what will happen then? And again apply the formula of GP, then 1 plus alpha raised to m plus alpha raised to 2m and so on plus alpha raised to m times of n minus 1 is equal to first term into common ratio alpha raised to m to the power number of terms n minus 1 divided by alpha raised to m minus 1, because common ratio alpha raised to m is not 1. That's why we are applying the formula of GP, because common ratio should not be 1. Then you can interchange these two powers. So you can write alpha raised to n raised to m minus 1 divided by alpha raised to m minus 1. Okay. So now you can see denominator is non-zero while the numerator is equal to 0. So this is going to be 0 because alpha raised to n is 1. Alpha raised to n is equal to 1. So alpha raised to n whole power m is 1 raised to m. So this is going to be Karthikeyan. Which DPP you want? Which DPP you want? So whenever I'll have a practice session, do you attend my special classes? All right. So next important point. This I hope this point you have got this point. That means let's use it. If I say alpha is 11th root of unity, okay, 11th root of unity, then find the value of, okay, 1 plus the alpha is equal to, you can write e raised to I 2 pi by 11. It's better way to write, say it, alpha raised to 2 pi by 11. Then find the value of 1 plus alpha cube plus alpha raised to 6 plus alpha raised to 9 and so on alpha raised to 30. Okay, find the value. Second, find the value of 1 plus alpha raised to 22 plus alpha raised to 3 into 22, sorry, 2 into 22, 2 into 22, then alpha raised to 3 into 22 and so on plus alpha raised to 10 into 22. This is the second sum. And third is 1 plus alpha raised to 9 plus alpha raised to 18 plus alpha raised to 27 and so on plus alpha raised to 90. Okay. So you need to find these values. Try this. Try to answer these questions. Then I'll discuss. First try you. Or you guys try it for a minute. Alright, so you can use this result which we have just proved, because alpha is 11th roots of unity and you are putting 3 power on all the roots. Alright, this is, you can write this, you can write alpha 1 raised to 3. 1 can be write 1 raised to anything, 1 raised to 3, then alpha raised to 3, then alpha square raised to 3, then alpha cube raised to 3 and so on. You got it? So when you put 3 power, because 3 is not a multiple of 11, so answer is going to be 0. All right, you can apply the formula of GP, no problem. Okay, if you can directly write the answer 0, you have all the terms, and with power 3, 3 is not a multiple of 11, so answer will be 0. Now in second case, it is 1 plus alpha raised to 22 plus alpha raised to 22 square plus alpha raised to 22 cube and so on. All right, alpha raised to 10 into 22, and its first term is 1 raised to 22. You can write 1 raised to 22. So you are putting 22 power on all the terms. So by putting 22 power, which is a multiple of 11, alpha raised to 22 will become 1, alpha raised to 33 will become 1, right? So this was 33. So it is going to be 1 plus 1 plus 1 plus so on up to 1. So that is going to be 11. 11 is the answer. Okay. Now the last one. So as I've discussed in the past, because it's what is this written? 1 plus alpha raised to 9 plus alpha square raised to 9 plus alpha cube raised to 9. All right, plus so on up to plus 20. Alpha raised to 10 power 9. Okay, this is the last root. Alpha raised to 10 is the 11th root. So because you're putting 9 power and 9 is not a multiple of 11, so again you can use the same result which you have used in question number 1. So answer is going to be 0 for this. I hope you got it. Now next important point we'll discuss. Just wait for a moment. Is it clear? Yeah, Vamsi, yeah, your answer is correct. Yeah, all 3 answers are correct. Very good, Vamsi. 0, 11 and 0. Now see, this x raised to n minus 1 can be factorized and always be factorized as x minus 1 because one root will always be 1 of this polynomial x raised to n minus 1. And rest of the polynomial will be n minus 1th degree, which you can write x raised to n minus 1 plus x raised to n minus 2 and so on up to x raised to n x raised to 1 plus 1. Okay, so see, this has roots 1 alpha square and so on alpha raised to n minus 1, where alpha is equal to e raised to I 2 pi by n. Okay, and right side also the equation is same, so they will have all n roots same. So this has one root as 1 and this equation will have roots. What will be the roots of this equation? Obviously the remaining roots of x raised to n minus 1, which are alpha square and so on alpha raised to n minus 1. Okay, so these are the roots of this polynomial. Okay, so if say alpha is equal to e raised to I 2 pi by n. Okay, so hence confirm that it is nth roots of unity. Then you can write that alpha square, alpha cube, and so on alpha raised to n. How many values? Alpha raised to n minus 1. Okay, so how many values you can see? N minus 1. So these are the roots of x raised to n minus 1 plus x raised to n minus 2 and so on up to x plus 1 is equal to 0. Alright, it's very important point. It's very important point. Sometimes he doesn't say that it's nth root of unity. What he says is, like, I'll give you one example. Okay, so it is written that alpha is okay. Okay. Somewhere suppose it is written that alpha 1, alpha 2, alpha 3 and so on up to alpha 7 are the roots of x raised to 7 plus x raised to 6 plus x raised to 5 plus x 4 plus x cube plus 1 is equal to 0. Alright, these are the roots. Then he is asking find the value of alpha 1 raised to 40, alpha 2 raised to 40, alpha 3 raised to 40 and so on, alpha 7 raised to 40. Okay, so try this sum. All right, let's see. So as I told you that this equation is basically one of the factor of x raised to 8 minus 1. Okay, so if you write x raised to 8 minus 1, you can write this x minus 1 into x raised to 7 plus x raised to 6 plus so on up to x plus 1. That means the roots of this polynomial are basically the roots of x raised to 8 minus 1. 7 roots. X, uh, x raised to 8 minus 1 has one root as 1. So leaving that root, the remaining complex roots of x raised to 8 minus 1 are basically roots of this equation. Okay, so you can say that alpha 1 is alpha, which is e raised to I 2 pi by 8. All right, 2 pi by 8. Then alpha 2 is nothing but alpha square, alpha 3 is nothing but alpha cube, and so on. Alpha 7 is nothing but alpha raised to 7, as simple as that. So these are the 7 roots of 8 roots of unity, except one. Now what you need alpha raised to 40, alpha raised to 40, alpha square raised to 40. So alpha raised to 40 whole square you can write, all right. Then alpha raised to 40 cube, okay, and so on. So I'm just interchanging the powers. Alpha raised to m, alpha raised to m whole raised to n can be written as alpha raised to n whole raised to m, and so on. Alpha raised to 40 whole power 7, right. Now this alpha raised to, because alpha is 8th roots of unity, so alpha raised to 8 is equal to 1. In fact, alpha raised to 8k is equal to 1, where k is any integer, all right. So this k is 40 basically. 40 is also 8k type, 8 into 5, all right. That means all these terms will become 1. 1 plus 1 plus 1 plus how many times? See how many terms you have? 7 terms. So this answer is going to be 7. So yeah, answer is going to be 7. So 7 is the answer of this particular question. I hope you understood this. Now the next important point. You can write let 1, alpha 2 and so on up to alpha n are the roots of x raised to n minus 1 is equal to 0. So again alpha 1 is alpha, alpha 2 is alpha square, alpha 3 is. So that means alpha 1 is basically e raised to I 2 pi by n, okay. Then alpha 2 will be e raised to I 4 pi by n, and so on. All right, so alpha raised to n minus 1 is equal to 0. It has 7 roots, n roots, sorry. Okay, so you can factorize this. What are the factors? X raised to n minus 1. So in the previous slide, we factorized this into two factors. One was linear, and the other was n minus 1 at 3 degree. In this, we are going to factorize it into n linear factors, okay? So first is x minus 1, then next it will be x minus alpha, then it will be x minus alpha square, then it is x minus alpha cube, and so on. X minus alpha raised to n minus 1. So they ask many questions based on this particular relation, all right, this particular factorization is a very, very, very important factorization to remember. It's very important factorization. Let's see how. So if I ask you the value of, find the value of 1 minus alpha, 1 minus alpha square, 1 minus alpha cube, and so on, 1 minus alpha raised to n minus 1, okay, where alpha is equal to e raised to I 2 pi by n, okay. No need to mention much. Alpha is given e raised to I 2 pi by n. That means alpha is nth roots of unity. Then it is written that 1 minus alpha into 1 minus alpha square and so on up to this you need to find. So see, it is because you can see the product of n minus 1 linear factors, and linear factor means you need to use this, okay. So use this. How do you use it basically? That's the main question. How do you use it? Think about it for a minute and I'll tell you the answer, solution. All right. So see, you can write this equation. You can use this equation here, and you can write x minus alpha into x minus alpha square into x minus alpha cube, and so on up to x minus alpha raised to n minus 1 can be written as x raised to n minus 1 upon x minus 1. All right. You need to put 1 in this, but these factors are basically the factors of x raised to n minus 1 plus x raised to n minus 2 if you cancel x minus 1, right, plus x plus 1 actually, right, because you know these are basically the factors you need to use that previous factorization, this one, okay, this one. So this will be the product of n minus 1 factors, leaving the factor of x minus 1. All right. So yes, obviously you can write this. You can write this x minus alpha into x minus alpha square, x minus alpha cube, and so on up to x minus alpha raised to n minus 1 can be written as x raised to n minus 1 plus x raised to n minus 2 plus so on up to x plus 1. Yes, you can use this. If you don't want to take this factor of x minus 1, then just leave that factor, and the product of remaining n minus 1 factors will be this n minus 1th degree polynomial. All right. So you can say you are not cancelling x minus 1, but you are just multiplying these n minus 1 factors and you'll get this. All right. So in this, you need to put x is equal to 1 because this is an identity. Left hand side you have written in factorized form, and right hand side is a product expanded form. All right. So basically you are equating the same polynomial with the same polynomial in another form. Like you are writing x is equal to x. Like you are writing x square minus 1 is equal to x minus 1 into x plus 1. So it's an identity, right? So identity means you can put x, any value of x in this. So if I put x is equal to 1 in this, all right, put x is equal to 1, you'll get the required result. So you'll get 1 minus alpha square, and so on, 1 minus alpha raised to n minus 1, and this is going to be 1 plus 1 plus 1 plus so on up to 1 plus 1, and this is nothing but how many terms you can see, up to x raised to 0 to x raised to, you can see n terms. So this answer is going to be n. I hope you understood this. Is it okay? So in this way you can write the answer of this. You can frame many such questions. Okay, so I'll give you another question. Note these 2 points. These are very important points. So I've used this second one, this one. Okay. Now let me give you one example. So you find the values of first. You need to find all right. So find these values where alpha is e raised to I 2 pi by 11. Right. So by writing that e raised to I 2 pi by 11, you should know that what is this alpha actually. Okay. So at least you must be getting that alpha is nothing but 11th root of unity, right? So alpha is nothing but 11th root of unity. All right. So let's write this relation because alpha is the 11th root of unity. So we can write um, x x minus 1 into x minus alpha into x minus alpha square and so on up to x minus alpha raised to 10 will be the last, right? Is equal to x raised to 11 minus 1. And further you can write x minus alpha into x minus alpha square and so on up to x minus alpha raised to 10. Yeah, can be written as x raised to 11 minus 1 upon x minus 1, or you can write x raised to 10 plus x raised to 1 and so on. Okay, so in the first one, put x is equal to minus 1, okay, in 1. Why minus 1? Because if you put x is equal to minus 1, this will be minus 1 minus alpha, and after taking minus common, it will become 1 plus alpha, right? So that's why we are putting minus 1. Okay, we'll take minus sign common and it will become 1 plus alpha square 1 plus. So first you'll get this. First you'll get this relation as 1 minus alpha minus 1 minus alpha square and so on minus 1 minus alpha raised to 10 is equal to, if you put minus 1, it will be minus 1 only. Minus 1 raised to 11 is minus 1 divided by minus 1. So it is going to be 1 only actually. How many factors you can see here? 1, 2, 3 and so on up to 10 factor. So from each factor minus sign will be common, right? So from each factor if you take minus sign common, it will be minus 1 raised to 10 and it is going to be 1 plus alpha square and so on up to 1 plus alpha raised to 10 is going to be 1. So this will become 1. So final answer of this is equal to 1. So that is the answer. I hope you have got it. Now let's solve the second one. Find the answer of second one. Sorry. So use the same factorization again. This one. Equation 1. So put x is equal to 2 in 1. Alright. So you'll get 2 minus alpha square and so on up to 2 minus alpha raised to 10 is equal to, what will be this? 2 raised to 11 minus 1 upon 2 minus 1. This is pretty straightforward. So answer is 2 raised to 11 minus 1. Alright, that's it. This is the answer. Now the last one. See how to do it. Try this. What to put in this? Tell me, Vamsi. What are we supposed to put in this to get the result? Yes, of course, x is equal to minus 2. Good. So now put x is equal to minus 2 in equation 1. So it is going to be minus 2 minus 2 minus alpha minus 2 minus alpha square and so on minus 2 minus alpha raised to 10, okay, is going to be minus 2 raised to 11 minus 1 upon minus 2 minus 1. So you can see 10 factors are there. From each factor minus 1 will come out as we did in the first question. So minus 1 raised to 10 will be out. It is now 2 plus alpha square and so on 2 plus alpha raised to 10, all right, is equal to, this minus will come from the You can take minus sign common from numerator and minus from denominator. So it is going to be 2 raised to 11 plus 1 whole divided by 3, okay? And this will become plus 1. So this is the answer only, all right? This is the correct answer. So this value is equal to 2 raised to 11 plus 1 whole divided by 3. All right? That is the value. Now, the next important point is to find these values. Sigma of sine 2k pi by n, k from 0 to n minus 1, all right, and sigma of cos 2k pi by n. See how to find the values of these two. This is basically the second equation is basically sum of real parts of nth roots of unity, and the first one is sum of imaginary parts of real roots of complex roots of unity. Sum of imaginary parts of nth roots of unity. All right. So this is what we need to use. We know that one alpha is equal to, let's say, let alpha is equal to e raised to I 2 pi by n. Okay, 2 pi by n. That means alpha is nth root of unity. Then we know that sigma of alpha raised to k from 0 to n is equal to what? 0, 1 plus alpha square and so on up to alpha raised to n minus 1. This will be 0. Sum of all the roots of unity is 0. Then write this in Euler's form. Euler's form means put the value of in terms of e raised to I 2k pi 2 pi by n. So it is going to be e raised to iota 2k pi by n, k from 0 to n minus 1 is equal to 0. All right. Then it is going to be sigma of cos 2k pi by n plus iota times of sine of 2k pi by n. All right, k from 0 to n minus 1, sum of all the real parts plus sigma of sine of 2k pi by n, k from 0 to n minus 1, okay? Sum of all the imaginary parts into iota is equal to 0. So now you can compare it with 0, 0 plus iota 0 like this. So real part is equal to 0 and imaginary part is equal to 0. So it is going to be sigma of cos 2k pi by n, k from 0 to n minus 1. This is going to be 0. And sigma of sine of 2k pi by n. Right? This is equal to 0. Okay, so these values are 0. So let's see which kind of questions they ask. So for example, you need to find the value of cos of 2k pi by 11. All right, 11 sigma k start from say 1 to 10. All right, that is your question. First example 2, sigma of sine of 2k pi by 7, k start from 1 to 6, that is a question. And third one is sigma of sine 2k pi by 19 minus iota times of cos of 2k pi by 19. Alright, k from 0 to 18. Alright, so try these questions, try these sums. Alright, so you know that sigma of that sigma of cos 2k pi by 11. By looking at this 11, you'll come to know this real part, sum of real parts of 11th roots of unity. Okay, so k is starting from 0 to 10. Okay, now this is sum of all the real parts. Should start from 0 and up to 10. If it is starting from 1, then it should be up to 11. That means consecutive, there should be 11 consecutive values of k. All right, any 11 consecutive integers. So generally it starts from 0 to 10, but even if you take it from 1 to 11 or 2 to 12 or 3 to 13, then also fine, then sum will remain 0. But in this case, you can see it is starting from 1 and ending at 10. That means 0 term corresponding to 0 is missing. All right. So if I write this first term separate, cos 0, this will be cos 0 plus sigma of cos of 2k pi by 11. K start from 1 to 10. You can see what have I done? I have separated this first value, which was corresponding to k is equal to 0. So cos 0 is now separated and we need this sum. So this sum is equal to cos of 2k pi by 11 from k is equal to 1 to 10. This is going to be minus 1. All right. So this is going to be our answer. I hope you got it. Now let's try the second one. So in second one, you know that this, by looking at this number 7, this is 7th root of unity. So for 7 consecutive values of k, you will get sum is equal to 0. So sine of 2k pi by 7. So k starts from 1, then up to 7. K starts from 0, then up to 6. All right. This sum is going to be 0. But in this question, k is starting from 1 and up ending at 6. You have only 6 values, not 7 values. So first value is missing. What is that first value? Separate it like you have separated in the previous question. So for k is equal to 0, it will be sine 0. Separate it and write the remaining values in sigma. So sine 2k pi divided by 7. K starts from 1 to 6. This is equal to 0 and sine 0 is number basically 0 only. So that means nothing will change. It will remain 0. All right. So this value will come out to be 0. This value will come out to be 0. I hope it is clear. Now the last one. So in the last one, if you distribute sigma, this is going to be sigma of sine 2k pi by 19. So that means there is 19th roots of unity. K starting from 0 to 18. Perfect. You have 19 terms. So now this will become 0. Minus iota you can take outside the sigma. And sigma of cos 2k pi by 19. Alright. K starts from 0 to 18. So yes, you have all the terms in this. So this value will be 0. Now all the terms in this will also be 0. So it is going to be 0 plus iota times of 0, which is equal to 0. All right. So answer of this will be 0 only. Understood? So this was all about Nth Roots of Unity, right? Uh, so we'll have a practice session later. This was the theory part of Nth Roots of Unity. We can do some other things also. So in next session, I'll continue. We'll discuss the remaining things. If anything, if any point is remaining, we'll discuss in next session. And we'll continue also rotation of theory of rotations, okay, of complex numbers. All right, so thank you very much for attending this session, watching the video. Like and subscribe the channel. Let's Crack JEE. And also like my video if you're enjoying watching them. And use my code Jeetenra to get instant 10% discount in Plus subscription as well as Iconic subscription. All right, so I've told you the details of both the subscriptions, Plus and Iconic. So take your subscription, and if you haven't taken the subscription yet, then at least attend special classes. All right, just download the learning app and start attending the special classes, which are completely free, and get a lot of uh, classes on good topics of physics, chemistry, and maths every day. So there's unlimited learning. You can get it even without subscribing the channel, without subscribing the Unacademy. All right. But if you want to follow a particular course, then you'll have to buy Plus. All right. Have to buy Plus.